All right, here are solutions to quiz 5 for Math 95. What we're doing here is very similar to this week's perfect problem, just asked to solve absolute value inequalities. Here's the first one. The way we solve this first one is we first change it into an equality, and you divide by 3, and then you consider two cases, either 4 minus x equals 6 or 4 minus x equals negative 6. So either negative x equals 2, so x equals negative 2, if you subtract 4 from both sides and divide by negative 1, or negative x equals negative 10, so x equals positive 10. So what we get are three regions. The boundaries of the regions are negative 2 and 10, our solutions from over here. And so our three regions, one of them's over here, one of them's in here, and one of them's out here. And what we have to do is test numbers from each of these regions to see if they satisfy these inequalities. So a number from this region, a number that's less than negative 2, maybe I'll get a little clever. Let's let x be negative 6. Any number that's less than negative 2 will work. But if we test this one, we got 4 minus negative 6 has to be less than 18. So is this true? Well, let's see. 4 minus negative 6 is 10. Absolute value of 10 is 10. So really we're saying is 3 times 10 less than 18. And that is not true. 3 times 10 is 30. 30 is not less than 18. So these guys are not solutions. In this next region here, choose a number, maybe 0. So our question is 3 times the absolute value of 4 minus 0 less than 18? Absolute value of 4 minus 0 is absolute value of 4, which is 4. 3 times 4 is 12, which in fact is less than 18. So those are in our solution set. And finally a number greater than 10. I don't know, how about 14? I chose 14 from this third region, because then 3 times the absolute value of 4 minus 14, is that less than 18, question mark? Well, let's see, 4 minus 14 is negative 10. Absolute value of negative 10 is positive 10. 3 times 10 is 30, that's not less than 18. So these are not true, so that's not in our solution set. So our answer is the only numbers that satisfy are the numbers that are from negative 2 up to 10. Notice parentheses in both cases because we're less than, not less than or equals to. Alright, this next problem, basically do the exact same thing. So we got 2 times the absolute value of 2x minus 4. We'll set that equal to 20. Absolute value of 2x minus 4 equals 10 if we divide both sides by 2. And now we can split this up into two cases. 2x minus 4 equals 10. And 2x minus 4 equals negative 10. Subtract or add 4 to both sides and you get 2x equals 14. So x equals 7. Add 4 to both sides and you get 2x equals negative 6. So x equals negative 3. Okay. Now we set up our number line over here. And we have as our boundaries negative 3 and 7. And so that gives us 3 regions. There's 1, here's 2, and here's 3. We'll test numbers from each region. Maybe I'll take negative 5 this time. So 2 times the absolute value of 2 times negative 5 minus 4. Want to know, is that greater than or equal to 20? Well, let's see. This is 2 times negative 5 is negative 10. Minus 4 is negative 14. The absolute value of negative 14 is 14. So 2 times 14 greater than or equal to 20. Yeah, that works. 2 times 14 is 28. That is greater than or equal to 20. So these are in the solution set. Switch colors and try something from this middle region. X equals 0 is always a good one to try. 2 times the absolute value of 2 times 0 minus 4. Is that greater than or equal to 20? Question mark. Well, let's see the absolute value. 2 times 0 is 0, minus 4 is negative 4. The absolute value of negative 4 is 4. 2 times 4 is 8, which is not greater than or equal to 20. So these guys are not in our solution set. And finally, something from region 3. Let's write this over here. Maybe x equals 10. Nice round number. 2 times the absolute value of 2 times 10 minus 4. Is that greater than or equal to 20? Question mark. Well, let's see. The absolute value of 16. 20 minus 4 is 16. And 32 is greater than or equal to 20. So these are in our solution set. So our answer is all the numbers from negative infinity up to negative 3. And this time we want to include negative 3 because it was greater than or equals to. And again, all the numbers from 7 up to infinity, again including 7. Alright, now we want to find the intersection of our two answers. I think the easiest way to do that is to graph. So in part A, we got negative 2, 10. So we wanted all the numbers in between these two guys, but not including those two guys. And in part B, we wanted everything that was from negative infinity up to negative 3. So we want to include that point and go out that way. And everything from, so here's 0 again, and here's 7, not necessarily drawn to scale, up to infinity. And so if we want to find the intersection, we need the things that are in both of these sets. These guys aren't in the top set. These guys aren't in the bottom set. But things from here up to here are in both. So maybe I'll call this intersection. So things from 7 up to 10 are in my intersection. So my answer, maybe answer is 7 up to 10. All right, union. I can look at this same picture, and now I can be like, to be in the union, you just have to be in one of these two sets. So if this is negative 3 here, all of these guys are in the union because they're in the bottom set. And then from negative 3 to negative 2, we're not in either set, but from negative 2 on up, actually all the way to infinity, we're from negative 2 to 10, we're in set A, and then kind of where we leave off on set A, we've already picked up on set B, and we go out this way. So this is our union of the two sets. Our answer we'd write as negative infinity up to negative 3, union negative 2 up to infinity, and you want to include negative 3 but not negative 2. Whew, and I think that finally is the answer or the end of this quiz.